Today's lesson, section 3D-E, will be writing equations of 3D surfaces. So they want you to write an example of an equation that satisfies the given conditions. So for letter A, it says the cylindrical surface is elliptical and parallel to the x-axis. Okay, now remember with cylindrical surfaces, when we write the equation, we're missing one of the variables. And the variable that we're missing is the one that you're going to be parallel with. So in this case, you want to exclude the x-axis, okay? Or the x variable. So that means you're just going to have y and z. And because you want it to be elliptical, you want your equation to kind of look like an ellipse in the cylindrical sense. So you have y squared, z squared. You have addition equals to 1, okay? Now, for your problems today, just as long as you have the good bones of your problem, like I need to have the y squared plus the z squared and equal to 1, okay, for that to be a true statement. But here, this is where you could have a different answer than your neighbor. So because it's an ellipse, it doesn't say what the a value, the b value are. There's not enough information to figure that out anyway. So we can just write in whatever numbers we'd like. So I'm going to write 20 underneath the y squared and 25 underneath the z squared. And that would be a perfectly fine answer. If you used 100 and 2000, that would be perfectly fine as well, because you're still fitting the ellipse sense. Now just make sure that they're not the same number, because then that would be a circle, and then you wouldn't have an elliptical cylindrical surface, you would have a circular cylindrical surface. Okay? Letter B says that it wants the surface of revolution, so the y-axis is the axis of revolution, and the traces in the other planes are circles. So here, because you want the y-axis to be the revolution, that one's the one that's going to be kind of like the ignored one, but you still need it in your actual equation to be a surface of revolution. And since you want them to be circles, circles have x, like if the 2D one would be x squared plus y squared, right? So you want the same thing with the ellipses that you had. All your stuff needs to be addition. Remember that when you're left with, like, if you take out the y squared, it needs to be a circle for it to be a, like, that's kind of what you're shooting for, or an empty set. But usually when you're doing this, you want to shoot for a circle. And so they need to be the same, okay? So x squared over something and plus z squared over something needs to be a circle for it to be the case. So those two numbers need to be the same. So I picked that therefore. Okay? Now, for this one, because the other traces are circles, that means when you block out z squared, the y squared needs to match the x squared, and if I block out the x squared, the y squared needs to match the z squared. So because I picked 4 and 4 for z squared and x squared, I need to put 4 underneath my y squared. So this one's actually ends up being a sphere. Okay? And that would be my answer. Okay? Letter C says the surface of revolution. Z-axis is the axis of revolution, and the traces in the other planes are ellipses. So here, same thing. Since you want ellipses, it's going to be x squared plus y squared plus z squared. So you want all pluses equals 1. Now here, remember if I block out the z squared, because this is the axis of revolution, the other two numbers need to be exactly the same. So I'm going to pick that they're 8 and 8. Now for the other ones, you need planes that are ellipses for your traces. So if I block out the y squared, x and z need to be different. If I block out the x squared, y squared and z squared need to be different. So I'm going to pick a different number than 8 to make ellipses. So I picked 12. Okay? And so that makes your ellipsoid picture that you should get. And so for this one, and for any other ones that we talk about, just make sure that, like if it says hyperbola, then when you block one out, then one needs to be x squared and the other one needs, or sorry, positive and the other one needs to be negative to be a hyperbola, if that's the surface of revolution. Make sure you go back to your equations to kind of take a peek at the traces that we got for those examples, because those will help you out writing your equations. Get used to putting the right equation with the right shapes. Okay? And then letter D says it's a sphere. So you know the equation for a sphere. The radius is 4, and it passes through the point 5, negative 4, 6. Okay? So here, because you know that the radius is 16, okay, and since you know it passes through a point, okay, you have a radius of 4. Now, it doesn't really tell you what the center is or tell you what direction. So you can kind of pick and choose what you want to do. So if I looked at this negative 4 here, and let's say that the center is on the same axis as the y-axis, okay, so if I took 4 away from that, I could say that my center is 5, 0, 6, because that point is technically 4 away from that, or from 5, negative 4, 6, because of the y value. So then I could just make that my center, and then say x minus 5 squared plus y minus 0 squared plus z minus 6 squared. Okay? And so that would be an example of an equation, but you could do the same thing with the x-axis and make it x minus 1, or you can make it x minus 9. Like, you can go in the other direction. So really you get to kind of choose what your centers or those kind of things are. You can kind of be a little bit creative in what you're doing. Okay? Have fun.